To make real big change, going from a mechanical breaker to a solid-state breaker is a leapfrog in technology. I'll be the first to tell you, not a new idea. We were the first to ever actually commercialize that.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about the benefits of a solid-state circuit breaker. It's a game changer, but even my guest admits it's not something most people think about. That's because it's everywhere, and as he puts it, Goliath. This is probably one of my most personal interviews. I actually worked for this company and was hired by my guest back in 2016 for a short-term project to help them get through some preliminary UL testing. For those not familiar, any electrical device, especially breakers, have to go through a series of tests to prove they can sit between you and electric current. I was tasked with running the project, keeping everyone on schedule. It was more educational for me because I was exposed to this new technology, and at one point during crunch time, found myself fabricating some of the breakers. As you can guess, most circuit breakers are a box with a mechanical switch that opens a circuit when there's too much current. It's a technology that's been around for 140 years. Solid-state circuit breakers use silicon carbide chips and can open instantaneously. In one of the earliest videos, my guest touched two wires together with 200 amps going through them. With most breakers, you'd see a big arc flash. This one closed, and you didn't even see a spark. It was like magic. He says the key benefit of a breaker that's also a chip is that it can control the flow of energy and speak to whatever device is on the other end. This eliminates a lot of hardware and software, and it's one of the reasons my guest has focused on EV charging as its first sector now that they're commercial. It's been a long road, but my guest has finally achieved that breaker breakthrough that was promised years ago. My guest today is Ryan Kennedy, CEO of Atom Power, a solid-state circuit breaker developer based in Charlotte. Ryan and I met not long after I first came to Charlotte. I was still working in the oil field sector, traveling up to Ohio once a week. Ryan offered me a part-time project management role, and I stayed with them until that round of UL testing was over. You'll hear me discuss a lot of ideas I've already covered in this podcast, particularly how you pick a sector you want to focus on when you're a young company. Ryan and I also cover some of the fine details of their breaker they call the Atom Switch that most other folks never ask him about. Granted, most of those Atlas never assembled one of their switches. I hope you enjoy my conversation with Ryan Kennedy. We hear Ryan Kennedy, CEO of Atom Power. And Ryan, this is the first time I've interviewed a guest I've actually worked for in the past. And it seems like this was a lifetime ago, 2016. We'll quickly try to catch up. When I first met you back then, your product, the Atom Switch, was on the cusp of its first rounds of certifications. What did those early tests and the eventual commercialization of this brand new product teach you and maybe could teach other people, broadly speaking?
Jay, thanks for having me on. It taught me it's really hard, to do pretty much anything that's got hardware related in the energy space, especially when you have something that is life safety oriented like the circuit breaker is. I think anybody who's looking at the electrification space in general probably would steer clear of circuit breakers because they're probably one of the most heavily regulated devices on the market, through UL and through the NFPA and their usage and things like that. I think that was probably at a technology level what was the biggest learning was how difficult that was going to be, both from a difficult technology wise, but also to navigate the codes and standards and the regulatory portion of that. It took a lot longer than we thought and quite a bit of effort.
Yeah, my involvement was you guys had just built your first prototype, injection molded plastic. We're putting those things together. We went out and did about a week or so of UL testing. Some was destructive testing. And I think we were all kind of thinking that'll be it. We'll be certified, right?
Yeah, I think there was a general notion at that time that there would be more steps involved. That was the first time we actually ever went through UL, or that level of UL testing, I should say. We were pretty unfamiliar with actually doing it up until then. And we had received our first, I would say, strategic investment right around that time period, which helped us do that. And so prior to that, we were largely treating nickels like manhole covers. So we had no opportunity to go to a big lab, with all this professional equipment and really do these big tests. We did as much as we could where we sat, which was on the campus of UNC Charlotte, but had never been through that level of testing. So I think there wasn't necessarily a notion that, we'll be done with that. There was a notion that we'll successfully get through it and learn where gaps would be, particularly related to the way UL does their testing and if there's any product modifications we would need to change as a result of that, and which we did absolutely out of that first round of testing. That was definitely one of the hardest things we probably ever went through, though, was that first batch of testing to really vet out where you stood as a product. But it did uncover things we need to work on, but also uncovered the power of what we were doing. We were able to perform significantly higher than any breaker the testing technicians had ever seen with major things like short circuits and things like that. But it was definitely a good experience. Very difficult one. Very difficult.
Yeah. In the monologue, I'll also take listeners through the fundamentals of the atom switch and how it works. But I'll let you explain to folks what a sea change this is for breaker technology, because you had fuses at the very beginning of the Edison days. You had breakers, which was what most people know today. And then you have this, right?
Right. So breakers, it's clearly a cliched thing to say today that no one thinks about them, which is absolutely true. It's something most people know about largely because of their homes. And breakers exist everywhere that there's electricity. And a breaker has this unique feature in the sense that most products that were developed through the ages, generally speaking, the killer application changes over time. The phone is clearly the epitome of that, right? The phone call is not necessarily the killer application anymore, despite it being the original purpose of the phone and us still calling it a phone. The breaker, on the other hand, the killer application for the circuit breaker when it was first patented way back in the day, in the late 1800s, was to protect circuits from excessive current. And it remains the killer application today for circuit breakers, 140 years later. That is achieved exclusively by mechanical mechanisms within the little box or big box, depending on what industry you're in, that opens the breaker. And so think of it as a pretty sophisticated mousetrap today, largely, and has been for over a century. What we've done differently is to basically say, well, if everything after a circuit breaker requires visibility and control, so think like HVAC, charging vehicles, lighting controls, you name it. We actually do a lot of stuff with electricity today, but we add things on top of circuit breakers or after breakers to go do that, to just have software control over something. We basically said, could the breaker be that product that ultimately through software is told what it is? Instead of buying breakers and also buying specific purpose-built products to perform a function after it. That's actually what EV chargers are, for example. They provide control and visibility to charge a car, same as HVAC does for cooling a house or a building. So we basically said, could you build in not just the protection, but the visibility and control system within a circuit breaker, and more ideally, make that software defined? At the sort of highest level, could I buy a breaker and through software tell it it's an EV charger or tell it it's an HVAC controller on top of being a breaker? And so that was really the goal of Atom Power from a technology standpoint. So to do that, you have to recognize it's like saying, compare the breaker to a rotary phone. It's hard to say, take the rotary phone and make it a smartphone based on the same physics you have in the rotary phone. It's actually impossible to do, being purely mechanical. So the only way we found a way to sort of make the breaker the device that can do anything is to make it solid state. And that basically means to use semiconductors instead of mechanics to control the flow of energy, to actually switch on and off and things like that with regards to energy flow, like talking big energy, the energy to go feed a car or a light or something. Once you do that, you shift from the rotary phone to the sort of smartphone instantly, because now you're semiconductor based and you're not mechanically based. We were the first to ever actually commercialize that. I'll be the first to tell you, not a new idea. Solid state breaker ideas and experimentation has been around for a bit over 40 years now. It's been kind of the holy grail of power distribution for a long time. I mean, you can go way back and see a lot of publications on this, but Adam Power was just the one that happened to commercialize the first ones.
Yeah, I've discussed this idea a lot over the years on the episodes of this podcast, but I first remember exploring this idea with you, and that's the idea of what do you do with a technology, in this case a breaker, you just said it, that can be used literally billions of places. And what do you do when it's early days and you need to focus on maybe one sector at the beginning and not spread yourself too thin? Why is that important? And ultimately, what were the decisions you made in those early days on that?
Yeah, absolutely. And I'll sort of preface that with, to make real big change, going from a mechanical breaker to a solid state breaker is a leapfrog in technology and capability, fundamentally, whether we did it or someone else. To some degree, you can't look at doing that how you would look at a typical startup. You know, a typical startup says, find a problem and find a better solution for that problem. Be faster, cheaper, more efficient, something. Any change like this is a new category. Put cars in that category. And in those markets, to some degree, you have to recognize that you're actually a hammer looking for a nail there, because there is no market for that today. You're making a bit of a bet, but it's a sound bet that says, well, is it better fundamentally to have one product or 20 other products to achieve the same thing? Well, it's better to have one, and that one thing can be universal. So there is some business case, I would say more of a fundamental business case for things that create big shifts and create new categories, which solid state breakers are, cars were. So you have to, as a young company, look at it differently and recognize that you're a hammer looking for a nail. You can't go in initially and say, we're going to do this and our specific commercial approach is right there. It's instead the most important at the time to say, well, since it's so fundamental and can impact, as you were saying, millions and millions of applications, across the globe, you kind of need to get like the fundamental foundation right first. Create the platform that allows you to go then pick the market. That was a large portion of our beginnings, a good 4 years, I would say. But then you reach a point that says, okay, we're on our second generation. First generation was the first to get through UL successfully, first ever in the world. Second generation, we had come out later that same year. This is 2019. And then markets started pulling at us. What I learned through the process was that's okay, but make sure you vet out the kind of markets. You start getting into a commercial mindset more, I would say, at that stage. We didn't so much. We reacted a lot. So we had a lot of industries that were kind of pulling from us to say, hey, we could use a breaker here. We did a lot of pilots and installations largely related to the data center and industrial spaces, which have excellent applications for this. Our challenge was those are such big industries and widely diverse that we could see that we were such a small team at that time, 2020, roughly 20 to 25 people at that time, that there was no way we could actually support those industries with the size we were then. Not effectively, because every application was different. And so there's ways to address it now. But then we were looking at it as in, wow, a lot of integration per site here. So at that same time, thankfully, we were seeing that there was this pain point that was emerging that was related to charging vehicles at scale, which isn't to say the pain point was charging the vehicle. That's kind of been done for a while. It was more to say that once the scale started, anything from fault currents to energy management to pain points about not having smart equipment in front of the vehicle, to where we basically said, can we address that with what we have? And largely, yes, we had actually built a solid state breaker that could also be an electric vehicle charger. And great news is we build panels too, so we can put this all on a panel and basically charge cars from the circuit breaker. And the applications are relatively similar. It's not a ton of variability in that application. So by 2021, we made the decision to say we probably need to focus on that industry, large scale electrification of vehicles. We finally realized, yes, to your point, we had to go pick a specific market, specific application as repeatable as possible because, as you said, a breaker sits ahead of everything that consumes energy, which basically means that your market is absolutely Goliath. But we eventually did get there. Yes.
That's a great answer. I think that also is a demonstration of, there was some book I read in business school, I think it was called Good to Great, where they talk about something called the hedgehog principle, which is these companies that just laser focus on one thing. And this laser focus on EVs is pretty extraordinary. I mean, looking at your website and everything, I mean, it is EV EVs. But I'm curious, is there any discussion about maybe branching into something else after EV charging at this point? Or is it just EV charging? This is what we're going to be doing for the foreseeable future?
Good question. Let me answer that in a pretty colorful way. Part of the learnings of picking your initial market that you really want to go after and do really well with a product that spreads to all electrical markets is you have to have, or Atom Power has had to live two worlds. One is to say that's our market focus. But for us, it's an application of the product. We don't consider ourselves a EV charging company. To us, EV charging is an application of the fundamental platform. It can do many other things. The second hat is, as we're progressing in that market behind the scenes, we are absolutely going into other markets. It's a matter of timing, because what we want to do is optimize certain features of the product to enable that more easily, is the short version. We have a Goliath market to tackle today, which is electrification of vehicles. But again, for us, that's an application, but we have to focus on that application while behind the scenes, we have to also be developing for other markets as well. And we've certainly tagged those markets. What's next? What's next? What's next? But it's not like EV charging, then that, then that. It's more like EV charging, continue EV charging, but also the same product now can be applied to industrial controls and data centers and even residential down the road. That's kind of how we view it. But it's a tough world to live because you kind of have to have two worlds you live in consistently,
Yeah, absolutely. When I was with you guys, the heart of these breakers was the chips, the MOSFETs, which allow for lightning quick circuit breaking. The trade-off was that they would get hot. They're basically like chips that you'd have to dissipate heat from them like you would your laptop. Has any of that underlying technology changed the heat issue, maybe even using MOSFETs? Did you find another vendor or technology you could sub out that you liked a lot?
Yeah, you're bringing up a great topic, and one that even I overlook when talking to folks is that, Atom Power is really a semiconductor company too. Behind the scenes, again, a couple things behind the scenes, but one of the major things is silicon carbide as a semiconductor is really an enabling technology at the fundamental level to enable solid state breakers. And that allows you to be much more efficient, power dense, and something you alluded to is that, yes, when you flow power through semiconductors, the side effect is you can create a lot of heat. More problematic is the intensity of the heat in a local area. This was actually the problem with the early LEDs. Early LED light bulbs had heat sinks on them. Atom Power also had to innovate on the silicon carbide power module. So we created our own to be extraordinarily efficient and to extract heat away from the semiconductors very quickly. It's not to say that it's inefficient. It just has different dynamics in the sense that, heat can dwell for a long time in copper, for example, or metal. For a semiconductor, you have to get the heat away quickly. Being 99.9% efficient sounds like there's not much heat there, and there's really not. But where it exists, the semiconductor, you have to get that away quickly. Same problem that early LEDs had. Solved in different ways with a solid-state breaker, but it's being solved continuously. So we're continuously evolving our own modules, and certainly you're getting help from the silicon carbide industry, which is growing large today, from companies like Wolfspeed, Infineon, ROM, that are clearly putting a lot of investment into building out silicon carbide plants. So we had to first build our own modules to address a lot of those issues, our own power modules, which kind of planted us now in the semiconductor space, which is kind of ironic because there are entire companies built around just producing a module. We just kind of do it a long way, And then as we're doing that, we have the benefit of the silicon carbide industry growing rapidly, largely because of electric vehicles, which also use silicon carbide for their power conversion. The improvements are fairly consistent on what is happening with silicon carbide fundamentally, but also what we're doing in packaging that into power modules for our own products. So continuously getting more power dense, more efficient, which enables us to get smaller and more cost effective, things like that through time.
Yeah, those original MOSFETs weren't purpose built for this, right?
Nope.
What were they built for?
We don't actually know. They came from a certain vendor at the time that they were likely being used in electric vehicles somewhere, or at least some power conversion applications, almost certainly in power conversion. We were taking those as discrete components, think of it that way, so individual MOSFETs, and assembling those as best we could to basically make what we needed for a solid-state breaker. That was our first generation approach. Good enough to get through UL, but we're limited on the full capability, I would put it that way. on at least, amperage related to largely heat problems. That changed in our second generation, as by then we had vertically integrated and created our own silicon carbide modules.
These circuit breakers, especially the little computers themselves, have built-in functionality that mechanical circuit breakers do not. You talked a little bit about the EVs, and in one of the videos showed basically a big parking lot and how you have a lot of functionality with charging across fleets maybe. So how are these special features that come in handy work for EVs?
Yeah, it's interesting getting into the EV space because it starts to feel detached from the solid state breaker for sure, and that's something we had to acknowledge and realize. So part of the commercial approach to selling the solution is not to say, hey, use the solid state breaker to charge your car, even though that's what we do, is instead saying, hey, fundamentally based on the architecture and having intelligent breakers that can also charge your car so you don't have to have a charger out by the car. Also, we aggregate everything through software, highly secure, highly reliable software, so that you can create large-scale energy management on a campus or a facility or multiple campuses across the country. It's quite easy to do that. Additionally, we address certain things such as reliability. Again, not speaking of solid state breaker, but the inherent reliability is related to the solid state breaker, meaning that Atom Power fundamentally is built differently than other competing companies. We're built as a breaker per the breaker standard, which is a much more robust standard because breakers have to work. It's like if you read about the status of the reliability of EV charging in the U.S., it's pretty bad. Actually, the uptime is approaching 70% these days, which is not good. But for us, we have to work because we're a breaker. Also, we're simultaneously an EV charger and a breaker, and that translates to pretty high reliability, like really high reliability. Actually, that tactically works out also to repeatability. How many times can you use a competing EV charger is often a question. I can tell you it's a few thousand times. For, Atom Power, that can run into the millions, the number of operations, just based on the nature in the architecture of a solid-state breaker doing those things, because you have no degradation of the product, or very little, I would say, through the switching operations. You mentioned fleet. Fleet is certainly one of our markets, hospitality and multifamily, charging at scale. We approach it from the aspect of, do you want highly reliable, high secure, and high uptime through your product that can scale across any facility, doesn't matter what it is, based on the high fault current rating we have, and is highly repeatable for your systems. There's a solid state breaker and a high tech thing behind that, right? But that's what enables us to actually sell in that way, is because we have this foundational technology in the background that allows for that high reliability, high repeatability, high security, high safety. You know what I mean? So that's how we kind of go to market in the EV charging world. It's not so much like, here's a solid state breaker that charges your car, but really it's trying to recognize value out of that, such as that reliability and large-scale energy management.
Yeah, I'm sorry, did you say that chargers are down 30% of the time?
Yeah.
Oh, wow.
There's a reliability challenge right now across the U.S. with charging.
Wow, that's super surprising to me, Ryan. That's a crazy number. And then finally, you probably told the story a million times. It was certainly compelling when I first met you, but your exposure to circuit breakers and arc flashing in particular didn't come from a lab in college or a textbook. It came from personal experience you gained, I believe, before you got your degree. How do you think that practical experience gave you insights that led you to Atom Power and where you guys are today?
I think it's everything Atom Power, for sure. Not necessarily that the idea for Atom Power got kicked off 28 years ago at this point, but my first experience was 2 weeks into the trade. So I was an electrician for 6 years, out of high school. And my first experience about 2 weeks into the trade was getting hit with an arc flash, meaning boom, fireball. Something really went wrong electrically on the job site. That at least gave me room to think that, wow, I kind of thought technology was further along than that sort of thing being able to happen, electrically. But then 6 years after the trade, going to college, UNC Charlotte for electrical engineering, and then designing buildings after that, and also managing the construction of buildings. So I've been in that construction space for the duration. That certainly all culminated together, along with some theories of the future, that there needed to be a universal device to offer safe protection, visibility, and control at the edge of the grid. And that's fundamentally the thesis of Atom Power. But yes, the industry piece and that experience, 20 years of that ahead of Atom Power, certainly influenced everything we do.
Yeah, well done. Well, definitely best of luck to you. All right, Ryan Kennedy, Atom Power, great to see you. Thank you so much for your time.
Yeah, thanks, Jay. Thanks for having me. Really appreciate it.
That was Ryan Kennedy, CEO of Atom Power, a solid-state circuit breaker company based in Charlotte. I want to thank Ryan as well as Matt Fleischel for setting this up. I also want to thank David Doctor, who I first met at E4 Carolinas here in Charlotte, for making the introduction with Ryan back in 2016. I was new to Charlotte and looking to get out of the professional rut I was in at the time. This work with Atom Power, along with other connections like Net Power from episode 55, showed me that there's a whole other world out there that I hadn't yet explored. That led me to doing this podcast and the incredible career I've had over the last 6 years. And I think it's only fitting to have a Charlotte guest to make a big announcement. While I'm certainly not saying goodbye to this show, we are saying goodbye to Charlotte. My wife and I are moving to Texas, to the energy capital of the world, Houston. I can't wait to share all the adventures we have down there, so stay tuned. Meanwhile, you can find plenty of pictures for this episode on energy-cast.com, as well as on Instagram at Host Energy and Twitter at Host Energy Cast. All guests are sent the wrong completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 167. Be sure to join us next week when we explore how one company is asking utilities to become partners in crypto mining. Until then, I'm Jay Downhauer. We'll see you next time.